Okay. So we have this rational expression, and they want us to simplify and state restrictions. So we can focus at it one at a time. In fact, what I'll do is kind of highlight, and we'll work on this one first. I'll do it in green on the side. So we have 3x minus 3. The quickest way to look at this is just a common factor. And if I take a look, I got to find common factors of 3x and 3. Well, I mean, x is a factor. I didn't leave myself a lot of room there. That's not a wonderful space. For 3, you can have 3 and 1 and x. These are all technically factors. And for 3 or negative 3, you have 3 and 1. We'll take the greatest common one, which happens to be 3 here. We don't always have to write this out. I just wanted to do the first one like that, just so you got the idea of it.
Yeah.
So what we're going to do is we're going to take 3 out of here, which means we have to divide both of the terms by the number 3. So when we're done with it, we'll have 3 on the outside. And inside the bracket, 3x divided 3 is just x. And negative 3 divided by 3 is negative 1. Okay? So our top part of the bracket, when we rewrite it over here, I'll do it in green, will just be 3 times x minus 1. Okay, so that's the first set. And I'm going to leave that bigger set of brackets around it. Maybe I should do that in black there. There we go. The next thing is we'll focus on the denominator. Why not, right? 2x and 2. I don't know if yellow shows up well, so we'll see here. 2x, can you see that? Plus 2?
Yeah, sort of. Yeah.
Sort of. Let's do it in black. It's a little easier. Doesn't have to be perfect. Okay. Common factor here, same as before. It's the 2. It's pretty simple to see. So we'll end up with 2. And inside the brackets, x plus 1. Are you okay with how we got that part?
Yeah.
Yeah? Okay. So then we'll write that underneath. We get 2 times x plus 1. And then in our other bracket, let's focus on the other two things. We have 5x plus 5. We'll do that in blue on the side. We have 5x plus 5. Same concept. Common factor out 5. We're going to have x plus 1. So 5x plus 1. And then our denominator on the other side. Let's do that in black. Our denominator, what color haven't I used yet? Red? There we go, I'll do that one in red. Will be 6x minus 6. Same concept, 6 is going to come out and we'll have x minus 1. So we get 6x minus 1. Okay, let's move back over and focus on this a little. So with that being said, and all our wonderful colors, there's a rule in multiplication that you can multiply in any order. It doesn't actually matter the order, and you'll end up with the same answer. So because this is multiplying fractions, think of everything on top in this like top row, the numerator. We can swap all of them around in different orders, and same with the denominator, okay? What that'll do is it'll help us line up some stuff, and we can do some canceling after. So we're actually going to write this out. I'm going to put a bracket around everything. You don't have to do this. It's a little tedious. But the reason I'm doing it is just so you can see how malleable these numbers can be. So I'm going to put 3 in a bracket. I'm going to put x minus 1 in a bracket. I'm going to put 5 in a bracket. I'm going to put x plus 1 in a bracket. And then I'm going to do the same thing on the bottom. Whoops. We got the number 2. We have x plus 1. The number 6. X minus 1. And these little brackets, think of them just like marbles, and we can put them in any order. It doesn't make any difference to our multiplication in the end. The reason is you can check this yourself. If I go 3 times 5, I get 15. And if I go 5 times 3, I get 15. If it's a commutative property or associative property, I can't remember the name of it, but there's a property that states we're allowed to do this in mathematics. So what I'm going to do is I'm going to line up some things. I'm going to put our constant terms first. We'll even go from lowest to highest. So I got a 3, then I have a 5, and then I'll just do x plus 1 and x minus 1. And again, you're going to be able to intuitively see these after a while and not really have to go through this reorganization step. But I'm just doing it to show how malleable, again, this can be. So we have 2, and then I move the 6 over. I want to line up. I have an x plus 1 on the bottom, so I'm going to line those up. And I have an x minus 1 on the bottom. I'm going to line those up. So we can quickly see that, hey, I can cancel out a whole bunch of stuff here, and I can put my constants together and get a value. But before we simplify, we want to state some restrictions, okay? Remember, we got to make sure the bottom here cannot be equal to 0. Now, if I do that, I'm going to take that denominator, I'm going to move it over to the side. We'll work on it over the side here. So we have 2 times 6 times x plus 1 times x minus 1 cannot equal 0, okay? Well, I want to get rid of this 2 and this 6. I can very quickly do that. I can divide this side by 2 and by 6, and I'll do the same over here. Divide this by 2 and this by 6. These create 1s or cancel out, and anything, 0 divided by anything, just leaves us with 0. So really, you could have seen it as, I'm just going to drop those two constant terms. They're not going to be important for what our restriction we're building. Here, though, we have two terms multiplied by each other, okay? So we split them. We're going to get 2 answers. X, so I wanted it to be back black there. X plus 1 cannot equal 0, and x minus 1 cannot equal 0, which means x cannot be negative 1 and x cannot be positive 1. And sometimes you'll see it written this way: x cannot be plus or minus 1 for your restriction, okay? Now that we have a restriction, we'll jump on back. Let's do some simplifying. X plus 1 on the top and x plus 1 on the bottom, they cancel and make a 1. Same with the x minus 1s. So we're left with 3 times 5 over 2 times 6. And then this is really simple. I mean, I could have dealt with this at the beginning. I know my multiplication tables relatively well. This is 15 over 12, or 5 over 4 as an answer. So we'll just quickly recap this. What we did here is we common factored each of the numerators and denominators. We did that all on the side here. Then we rearranged just so that it was simpler to see what can be simplified. In other words, what could kind of cancel out or create 1s. But before we did our simplification, we went over here and did our restrictions. And we got a restriction of x cannot equal plus or minus 1. And then once we simplified, there were no more variables. It was just some number. So this very complex looking equation simplified to 5 over 4.